NumPy is a Python module designed for scientific computation. NumPy has several very useful features. Here are some examples. NumPy arrays are n-dimensional array objects, and they are a core component of scientific and numerical computation in Python. NumPy also provides tools for integrating your code with existing C, C++, and Fortran code. NumPy also provides many useful tools to help you perform linear algebra, generate random numbers, and much, much more. You can learn more about NumPy from the website numpy.org. NumPy arrays are an additional data type provided by NumPy, and they're used for representing vectors and matrices. Unlike dynamically growing Python lists, NumPy arrays have a size that is fixed when they are constructed. Elements of NumPy arrays are also all of the same data type, leading to more efficient and simpler code than using Python's standard data types. By default, the elements are floating point numbers. Let's start by constructing an empty vector and an empty matrix. By the way, don't worry if you're not that familiar with matrices. You can just think of them as two-dimensional tables. We will always use the following way to import NumPy into Python. Import NumPy as NP. This is the import we will always use. We're first going to define our first 0 vector using the NumPy np.zeros function. In this case, if we would like to have 5 elements in the vector, we can just type np.zeros and place the number 5 inside the parentheses. We can define a two-dimensional array, let's call that 0 matrix, in the following way. We again provide only one argument to NumPy. In this case, it has to be a tuple. The tuple specifies two things. The first argument is the number of rows in the table, and the second argument is the number of columns in our table. So if we would like to create a 5x3 table, we type np.zeros, 2 parentheses, 5, 3, and 2 closing parentheses. Both the 0 vector and the 0 matrix will contain only zeros as their elements. We can see this if we type 0 vector, and similarly if we type 0 matrix. You can also construct arrays of ones using the np.ones function, and its syntax is identical to the syntax of the zeros function. To create an empty array, you can use the np.empty function, which allocates the requested space for the array but does not initialize it, meaning that the content could be anything, whatever happens to be in the computer's memory at the location where the array is set up. If you are dealing with a very large array, and you know for sure that you'll be updating each element of the array, this could save you some computation time because Python doesn't need to initialize the array. However, you should use this function with care, and if you're new to NumPy, it's probably best to avoid it at first. We can also construct NumPy arrays using specified values, in which case we use the np.array function, and the input argument of the function is a sequence of numbers, typically a list of numbers. In what follows, we assume that lowercase variables are vectors or one-dimensional arrays, and uppercase variables are matrices or two-dimensional arrays. To practice creating NumPy arrays, let's create 2 short one-dimensional arrays. Our first array is going to be called x, and it consists of the numbers 1, 2, and 3. Our second NumPy array is going to be called y, and that's going to consist of the numbers 2, 4, and 6. When you construct a two-dimensional NumPy array, you specify the elements of each row as a list, and you can then define the entire table as a list that contains, at its elements, each of the lists of the row elements you defined. Let's work through a simple example. Let's define the first row as consisting of numbers 1 and 3. Then we can define the second row as consisting of the numbers 5 and 9. So here we have two lists that are separated by a comma, and we will embed these two lists inside yet another list, and now we have our nested list object. To turn this into a NumPy array, we type np.array, and the nested list object goes inside the parentheses. Finally, sometimes you want to turn a table sideways. This is called taking the transpose of a matrix, which means that the first row becomes the first column, the second row becomes the second column, and so on. Notice that another identical way to state this is to say that the first column becomes the first row, the second column becomes the second row, and so on. We can transpose a two-dimensional array using the transpose method. If we go back to the array that we had here, let's call this A. We can use now the transpose method to flip the array around.